In the last video, we established that if we say a rate of change of population with respect to time is going to be proportional to the population, we were able to solve that differential equation and find a general solution which involves an exponential, that the population is going to be equal to some constant times e to some other constant times time. In the last video, we assumed time was days. So let's just apply this just to feel good that we can truly model population in this way. So let's give you some information. Let's say that at time equals 0, the population is equal to 100 insects. And let's say that at time equals 50, the population, so after 50 days, is 200. So notice it doubled after 50 days. So given this information, can we solve for C and K? And I encourage you to pause the video and try to work through it on your own. So this first initial condition is pretty straightforward to use because when t is equal to 0, p is 100. So based on this first piece of information, we could say that 100 must be equal to c times e to the k times 0. That's just going to be e to the 0. Well, e to the 0 is just 1. So this is just the same thing as c times 1. And just like that, we have figured out what c is. So now we can write the population is going to be equal to 100 e to the kt. And so you can see, expressed this way, our c is always going to be our initial population. And now we can use the second piece of information. So our population is 200 when time is equal to 50 after 50 days. So 200 is equal to 100 e to the k times 50, right? T is now 50. Now we can divide both sides by 100 and we will get 2 is equal to e to the 50k. Then we could take the natural log of both sides. Natural log on the left hand side, we get the natural log of 2. And on the right hand side, the natural log of e to the 50k, that's the power that you need to raise e to get e to the 50k. Well, that's just going to be 50k. And now we can solve for k. Divide both sides by 50. And we are left with k is equal to the natural log of 2 over 50. And we're done. We can now write the particular solution that meets these conditions. So we can now write that our population, and I can even write our population as a function of time, is going to be equal to 100 times e to the, now k is natural log of 2 over 50, and then that times t. And so if you assume rate of change of population is going to be proportional to population, and you assume this information right over here, this function is what is going to describe your growth of population. And we are done.